Next up, we have Andrew Bailey. Andrew is the Chief Executive Officer of MinEX CRC. He is a geologist with experience across exploration, mining and research coordination, both in Australia and abroad. Welcome, Andrew, and please continue to use Slido for your questions. Thanks.
Good morning. This is about stimulating exploration, and in a way it's a story about what MinEX, and I'll tell you about MinEX CRC, has done and how it's translating to what is carrying on and is going to carry on here in WA. There we go. So first of all, MinEX, Mineral Exploration Cooperative Research Centre. Cooperative research centres have been around for some 30 years. It's part federal funding of research into numerous fields, everything from animals to space to data. And there's been a few in the minerals field in the past, but this is mineral exploration, a 10-year life, co-funded by both federal cash and industry input and direction. So industry-driven, with researchers undertaking the research, industry putting up the ideas, and METS companies involved so that it can be commercialised and can be utilised. So quite a large cash budget over 10 years, a large non-staff in kind, being equipment and data, and then researchers, significant amount of researchers, about 100 at the moment scattered across the projects we're running, and so far 30 postgrads registered, and we'll be getting up to 50 over our life. So it's industry-led. It's important, efficient exploration knowledge, understanding, of course, safety and environmental factors, how we can do it better using data, informing decisions. And we've been running for 3.5 years now. The end of our first phase is coming up. So who are all these companies? Well, there's about 45 of them involved now. Some of the big miners, of course, Anglo, BHP, South32, significant METS companies, both Australian and overseas, some drilling companies, Mackay, for example, and then, of course, the Geological Survey, so all 8 surveys from the states and territories, as a key or a cornerstone being GSWA as well as Geoscience Australia, and then universities and CSIRO in Perth, Curtin and UWA, UniSA and Adelaide, as well as contributions from Tasmania, New South Wales, ANU and Newcastle, as well as junior explorers. So a number of junior explorers have signed up to be affiliates of the program to understand and be part of this exciting journey that we're on about doing research that helps the industry to find areas and open up the country for essentially further exploration and ultimately mining. So one part of it, and I'll show you the layout of the 3 areas, is this National Drilling Initiative, which we'll be talking about today. So basically that is a scientific drilling program. It's not pure exploration drilling, it's not research, it's scientific drilling program to basically generate to understand areas and ultimately generate targets. And effectively applying technology we're developing. So it's a test bed for what we're doing to open up areas and stimulate exploration around the country. This is a double clicker, but it works. So scope of MinEX, well, what are we doing? Well, we're looking at drilling technologies. How do we do it better? Everyone is drilling, let's do it more efficiently. Data from drilling, and I'll touch on that, and then, of course, this National Drilling Initiative. Not too sure if this is working, but if you're clicking at the back, it's working. Thank you. So the National Drilling Initiative one is a significant part of our program in different states and territories, and effectively looking at the value of data. And that incorporates everything from the portals that Simon was talking about a while back, how the data is made available and who can use it and how it gets out there and how it's spread. Looking at geological architecture, both cover sequences and basement, to understand all aspects of architecture, and then mineral systems that may exist or coexist or may exist in those areas. So on that basis, we're doing this initiative to A, understand areas, put data together, have it publicly available, as well as land up drilling it in places by ourselves, and of course for industry to drill it. We also look at other streams of our 10 significant projects, looking at drilling optimization. So we have a whole team at Curtin University doing both diamond drilling efficiencies, RC drilling efficiencies. We've got a rig set up in the lab. We have fluid monitoring systems. We've been drilling in South Australia, dosing fluids and controlling fluids from Curtin at the moment. So some quite advanced technologies on just improving the hundreds of millions of dollars that go into drilling every year. And then there's how do you drill better? And that's coiled tube drilling. And I'll touch on coiled tube and show you a picture of our rig also currently drilling at the moment on how to drill differently and better and cheaper undercover particularly. And then there's the data we generate. We've got a program at CSIRO doing laser ablation, downhole, applying laser ablation to put it down a slimline drill hole. A significant task ahead. We're 3 years in, we've got 2 laser labs. We're already firing lasers at moving rock and getting results from that. The next challenge is firing it at dirty rock, dirty moving rock, and then underwater dirty moving rock in a slimline drill hole. So it's a big project, but it's well underway. We're looking at petrophysics of logging while drilling, as well as applying seismics, fiber optics, down drill holes and on surfaces, both related though to the coiled tube drilling. And the reason why they related to coiled tube drilling is that here we have a drill rig, which I'll show an image of in a moment, that doesn't have drill rods that spin. If your drill rods don't spin, you can put power down the rods. You can put a fiber optic cable down. You've got comms to the head. You can drill to 1,000 meters and still talk to the head, which enables steering, which enables sensing, which enables EM and natural gamma, for example, which we've already got going at the bottom of your drill string. And applying all of those, as well as modeling it in 3D rapidly or simultaneously, which is a significant project with UWA and including the Loop consortium of rapid probabilistic modeling, and tying all that together with data from the National Drilling Initiative. So that's great, the NDI. Well, how's it worked so far? Well, we launched off into the Northern Territory last year based on 4 years of work from the Geoscience Australia's Exploring for the Future program. So this EFTF, Exploring for the Future, has been doing these large seismic lines across various parts of the country, and this area was identified as prospective. So there's good stratigraphy, there's prospective stratigraphy in an area centred where the 2 black lines meet there, essentially around the Barclay Roadhouse. So you're looking northeast of, from Alice Springs to the northeast and across to the Queensland border. And that scale on that, you can see where it's about 300 or in fact 400 by 400 kilometres, that area. So the area was identified as poorly known. The greenish spots on that were existing drill holes of significance, which there weren't many in an area that size. And the challenge was to go in there with a relatively small budget, $3 million, to drill 10 holes and let's see what's out there using better technology, exploring the area and being able to put that out for the public to do something and understand the area and explore further. So this is the East Tennant program. Basically, Geoscience Australia technical input. They selected a lot of the area based on the seismics. We then went off and undertook this program, a scientific drilling program. This is now being replicated in South Australia and next year in Western Australia and carrying on through the States. So we basically subcontracted a geological service provider, in this case Omni. DDH1 did the drilling. We had to get the full range of clearances, which of course varies from state to state. In the NT, there's the AAPA, the Aboriginal clearance, mine management plans required, paid bonds and get landholder approval, which is also a long process. And basically we got leases and we landed up drilling this. We had to get leases for ourselves to drill it. And in this program, we undertook 10 holes in the blue on this little graph, one way of depicting it. That's the cover sequence, generally RC or mud rotary through the cover, diamond tails, significant diamond tails in most of these holes. And we drilled this program of about 4,000 meters, scattered across 10 holes, targeting geophysical anomalies, unexplained anomalies and basins, but not targeting mineralization per se. It wasn't an exploration program, it was a discovery program. So we drilled these 10 holes just before the wet season last year, finished just before Christmas, did downhole geophysics, sent them to Darwin and Alice Springs, where they've also got a high logger machine, as has GSWA. We applied mineralize to all of them, so results were available relatively quickly, as well as then sampling for analyses, which are still ongoing, some of the analysis at various places. ANU doing, for example, argon dating on a lot of the rocks. So we drilled this program, 10 holes, you can see, took about 100 days, with significant data released, borehole completion reports, summary logs, composites. We ran geophysics, all the photography, of course, the logging, and it's all available on both the GA portal and the MinEX website. There's a portal there with plenty of data available to download and otherwise look at, as well as the 600 or so samples that have been taken, some of which are still being analysed. So this data was drilled and put out there, and from that point, they were targets, geophysical targets, but there was a little bit more than geophysical targets in a couple of these holes. This is a release from Inca Minerals. They were pretty happy because one of the holes was smack bang in the middle of their tenement, and we hit some significant, they've interpreted or put it out there as quite significant type mineralisation, 320 metres of IOCG alteration, including disseminated sulfides in the hole. So that is basically in a small tenement of ours, smack in the middle of one of their large tenements. And in fact, the hole ended in sulfides after the weather moved in. So the results were actually great for companies like this and great for many companies. And what happened after that? Well, we did one other drilling program, and then I'll show you the ultimate result. And that's where the red circle is on that map. We also drilled a single deep hole into a relatively unknown basin in the South Nicholson area. So this is south of the Beetaloo Basin, fairly well known for oil and gas occurrences, but a very poorly understood area outlined in the black dots, in the black dashes there rather. And you'll see on the top right-hand side, a couple of 100 k's away in Queensland, is Century Zinc. And the idea was to understand what is this basin and what's the potential for both mineral energy, groundwater, and to understand that basin. So this was the 11th hole effectively, but there's oil and gas potential in the area. Whilst we weren't drilling a trap site, we had to take all of the necessary precautions so that we could drill the hole safely. Now, if you thought the Nullarbor was a boring area, well, the Barclay Tableland, there's not much on it in that part of the world, and certainly when it rains, you don't want to be anywhere near there with black mud and a pretty flat area. So again, we used DDH1, one of their big rigs. We had all the clearances, we got exploration leases, and got a huge rig out there to be able to drill a 2,000, well, effectively we were planning a 2,000 metre hole, SQ core down to 600 metres, which is fairly chunky bit of core, PQ down to depth, with a short pre-collar section. So basically, a GA again selected this site using seismics, drilled the hole to 1,750 metres, and effectively went through all sorts of stratigraphy, which was both surprising but also expected. So that was great. We drilled to depth, got the core out, and what did we find? Well, before I show you what we find, it was a fairly significant task, as you saw on a $5 million budget. You just move a few camps in and put up some infrastructure, but it was a major task, including wireline analysis and testing. And it's just another picture of the site, pretty substantial to drill a 2,000 metre hole with that sort of outcome. Well, what did we hit? This is not a bit of driller's grease on the core. This is actually oil from a sample just come out, or should I say hydrocarbons. Definitely oil and gas potential, even though we weren't targeting a trap site. certainly migratory. There's gas potential, unconventional oil and gas potential in that basin, which is actually a significant find, and it's a new sub-basin that's been defined. So there's certainly information from that on the EFTF website, but even more significant is, or not more significant for mineral explorers, is the possible daylighting or the other end of the basin where Century is located. There's certainly zinc, and we hit sulfides higher up in the hole as well. So there's a lot of both mineral and oil and gas potential in that area that's going to be followed up by various companies. So that's great. We drilled this. What happens after you drill all this and put the data out there? Well, it's created quite a land rush. That area has now got 33 resource companies, and in a way we've created a problem because they're all out there exploring. Now the clearance, the native title system, the landowners are being overwhelmed. Everyone's out there trying to drill holes in the fairly limited annual season for drilling. We've also put together a small consortium ourselves and put a PhD on some of those results with Codes, University of Tasmania, and 4 of the companies are also, we're doing a PhD, which is great. So that's a summary of the 2 areas, and the East Tennant and the South Nicholson, again with those crossroads, Barclay Tableland. And you can see when we started this concept, after GA had run the seismics, there were 4 tenements across that area of some 400 by 400 kilometres. But people got wind of this and decided, well, this is a good idea. What are we going to do to follow it up? And by 2019, there were a few tenements popping up. A few people got out there and pegged early, which was good. And then it became pretty crowded, more and more. So by 2020, going well, and ultimately, if I can get that next one up, that's the picture now. So if you go to that, that's just amazing, actually, the way that's been covered and filled in even further in the last 3 months. So you go back on those, because I like these pictures so much. From 2019, started being taken up, and it was just all in, and that's where we're sitting at the moment. So the effect of spending, in this case, $8 million on 11 holes, putting it out there for everyone to access, there you've got a massive area of tenements taken up and 33 companies exploring, and this is what we're going to do in WA, and we're doing it currently in South Australia to stimulate the exploration, to stimulate ultimately finding of mines. So how are we doing that? Well, as I said, we're using technology as well, not just conventional, and this is a picture of our coiled tube rig. It's a bit unusual. It has at the top of the head there 500 metres of effectively NQ-sized hole that you're drilling on a coil. The drill bit is basically a downhole motor driven by fluids, by water, and with a lot of technologies going to the operating system, the fluids that keep the hole open. We're drilling an open hole here, open hole sample return, but the aim is ultimately to be able to have the integrity and the believability of those open hole samples to match diamond drilling, to be able to position it and sense it, as I said earlier, because you have comms and power to the head, to be able to steer that bit so you can steer towards or away from targets, and a 1,000-metre reach. We've actually got 2 of the rigs. We've built a 1,000-metre rig now as well. We're drilling with a 500-metre rig at the moment, and it's drilling in South Australia, the NDI program in the Delamerian area as we speak. We also have a conventional rig going to drill some of the holes, so we're twinning a few holes to prove them, as well as drilling some on our own with our CT rig and crew. Now, it's not just a rig, it also requires a processing system, basically a fluid handling system to back it up, but it's a combined package, drilling at less than diamond drilling will cost. And so that's just a summary. That's the East Tennant I was talking about in South Nicholson in the Northern Territory. We're drilling Delamerian at the moment. Next year, we're doing some industry work, as well as we're coming to WA here to drill the East Yilgarn work. So if you haven't got those tenements in that area, that's what may happen in the East Yilgarn area, as well as all those parts of the gap. After that, we're heading across to some New South Wales drilling, back probably to back to WA and in various parts of the country over the next 6 years still, applying this technology as a learning bed for ourselves, as well as opening up areas for industry. As I said, that's drilling at the moment right now in South Australia. I think we've got 4 diamond holes down, and in fact the second hole already, GSWA announced that some intense alteration, which was somewhat unexpected, and yeah, quite an exciting result already, which they've been putting out there in the South Australian drilling. And then lastly, I'll just finish with a picture. That is the coil tube rig. We drilled at Kapunda, just north of Adelaide, a couple of test holes to start. So you see in the foreground that truck with all the equipment on it is the hydraulic processing system, which contains remote units for fluids. It contains samplers, it's got a horizontal centrifuge and power source, and the CT rig just behind it, which is capable of drilling. It's got a 500-metre coil on it, and the last hole we drilled last week was to 490 metres. So we used up the coil, and it certainly works. And best shift was 190 metres in a shift, so it can certainly get through rock or get through ground, in this case Delamerian sediments, as well as recovering core at the bottom of the hole. We have a core barrel, so we got a couple of runs of core at the end of the hole. So not only can it go through cover at a rate, it can drill through hard rock as well. So that's the technology, and I'm sure there'll be a few busloads of people wanting to go and see it drilling in the East Yilgarn next year. I think that's it.